Our next lesson in our unit on circles is about arc length and sector area. So in our example here, it says the owner of a fish hatchery, which is basically just a fish farm, is sectioning off parts of a square pool to keep different kinds of fish. It says the fish will be kept in a circular area inside the pool, while the remaining sections will contain pumps, filters, machines, etc. So the trout will be housed in the area marked off by the dotted lines. Okay, so you see your dotted lines right here. And so it's telling you that the trout are going to live in this area right here. So if I just highlight this whole part right here, so that's where the trout are. All right, so we're going to want to figure out a couple things in this. We want to figure out the sector area, so the area of that highlighted portion, and then also the arc length, which is the measure of the arc out here on the outside. All right, so when I scroll down here, those are the two things we're going to find in these two examples down here. So the first question, it says, how much area will the trout have in the pool? Okay, so now we're talking about sector area right here. We know that the area of a circle, the equation I've already written there is pi r squared. R means the radius. If I want to just find the sector area that we talked about, okay, so once again, I'll highlight it in this picture. If I just want this area right here, we would use this equation. So the sector area equals the degree, which is the central angle, which right here we see is 120 degrees, divided by 360, times pi times the radius squared. Our radius right here is 50 feet. So we have the two things that we need. We have 120 for degrees, 50 for the radius. If we can just plug those two things in our equation, so we said 120 degrees on top of the fraction there, and then on my radius, when I plug that in right here, I'm going to put it in parentheses, is 50 feet. All right, when we put this in the calculator, I want to put 120 divided by 360 in parentheses because that's a fraction there. So I want to make sure I get the right number there. So I'm going to multiply that times the radius squared times pi right there at the bottom. When I punch all that in my calculator, I should get 2,617.99. And that's in feet squared. Our unit of measure is feet. Okay, so the area is a square unit. So 2,617.99 feet squared. All right, let's move on to the second example here that wants us to find the arc length. So it says the owner needs to enclose the area for the trout with netting, including the rim of the circle. How many feet of netting will he need? Okay, so we need to figure out what this arc length is here. I'll highlight this out here. So I want to figure out what the length of that arc is right there. All right, we know that the circumference of a circle, the equation for that is 2 pi r. So if I want to find arc length, which I've just abbreviated as AL right here, we want to use that same fraction that we used before. Okay, there's my degree still of that central angle, 120. So if that's 120, we know this degree measure out here on this minor arc is also 120 degrees. And then times 2 pi r, once again our radius hasn't changed, it's still 50 feet here. So I'm going to use the same two numbers again, so 120 for my degree, and 50 for my radius. Now, when I plug those in, all right, this time, once again, I messed up my fraction there at the bottom, didn't I? Where's that? That's supposed to be 360. There we go. All right, so when I punch that in the calculator, once again, put that fraction in parentheses right there. All right. All right, once I do that, I should get 104.72. Now, I'm not done quite yet on this particular problem because remember, it wanted to know what the entire netting would be. So I need to add in this part right here of this dotted line and this part right here of this dotted line. So I need to add two 50 foot nets right there. Okay, so when I do that, so I'm going to add 100 to this to get my final answer in this particular problem. Okay, so the arc length was 104.72. We added another extra 100 feet of netting in, so my final answer here would be 204.72. And that's going to be in just feet. This time we're not talking about feet squared because our unit of measure here is just in feet. Okay, we didn't do area here. So we're just in one dimension. So on page 2 of our notes here, we're going to do a couple more examples of finding arc length and sector area. All right, so my first one, it tells me we're looking at sector BAC here in our picture. All right, the two things that I need, once again, are our angle measure, okay, which right here they tell me that arc angle right there is 40 degrees, and we also need the radius. The radius right here is 9 millimeters. So we can go back in and throw those two things in the equation that we just used. Okay, we said that the degree measure goes on top, so 40 goes on top, 360 on bottom. Okay, once again, we're trying to find sector area here, the area of that shaded region. So we're going to multiply that by pi r squared. So by pi times the radius, which we said was 9 squared. Okay, once again, I can just throw all that in my calculator just the way it looks. All right, when I do that, my final answer should be 28.27. All right, once again, that's going to be in units squared. My units here was millimeters, so millimeters squared. Okay, look at number 2. Okay, this time the only thing that changes are the numbers here. We're looking at sector UTV here. There's my angle, 75 degrees. There's my radius, 12 inches. So let's use those two numbers in our equation this time. So 75 goes on top of my fraction. 360 still on the bottom. We're going to multiply that by pi r squared. Pi, my radius here is 12. Okay, once again, if I'm going to put that in the calculator, I want to put parentheses around my fraction here. Should have done that on the first one too. Hopefully you did that. All right, when I throw all that in the calculator on this one, I should get 94.25 inches squared. Okay, I'm going to jump down here and do 4 and 5 next, because these two we're trying to find the arc length. Okay, you see here they're asking me right here for arc length AB. All right, so if I look out here on my circle, let me highlight that. There's that arc length AB right there. All right, the two things I need, once again, the degree measure, which it says out here is 140 degrees, and the radius right here, which is 18. So let's put those two numbers into our arc length equation this time. So I've got 140 over 360, and this time I'll multiply that by 2 pi r, because we're talking about arc length here. So 2 times pi times my radius, which is 18. Okay, once again, put these fractions in parentheses, just multiply that by 2 by pi by 18, punch all that in your calculator. When you do that, you should get 43 point, my decimals aren't coming up good, there you go, 0.98. All right, and this time we are in meters, so in meters there. Okay, let's look at number 5. Okay, we're looking at the arc length right here. It asked me for the arc length of LM. Okay, once again, what are the two things I need? My degree measure here, my radius right here. Okay, and we're trying to find this arc length between L and M, little arc right there. All right, so my fraction this time around, let me just put a bar right here. My fraction will be 60 over 360. Multiply that by 2 pi r. So times 2 times pi. My radius we said was 3. All right, put that fraction in parentheses before you put it in the calculator. Multiply all those things together. You'll get 3.14. And that's going to be in feet this time. So there's my final answer there. Okay, I'm going to jump back up here and complete question number 3 now. Okay, I want to find the area of the shaded region. So you'll notice here that that shaded region is just this part right here at the very top. That's not a very good highlight, but you get the idea. All right, so up here at the top I have this little bitty triangle inside of this sector area, right? So I need to figure out what the area of that sector is, and then on top of that I need to figure out the area of the triangle, and then if I subtract the two I should be able to get my final answer for that shaded region. Okay, so let's start out with the sector area, what we've been doing. So right here I have 8 as my radius. All right, and then what's my degree measure here? Well, you see that little box right there in the corner? That means that this is a 90-degree angle, so this is 90 degrees out here. All right, so when I'm doing my sector area here, remember My degree measure goes on top, so 90 goes on top. 360 goes on bottom. We're going to multiply that by pi r squared. So times pi times my radius, which is 8 squared. All right, if I punch all that in my calculator, once again, throw that in parentheses right there. If I throw all that in my calculator right there, I will get 50.27. All right, and that's going to be in meters squared. Okay, now that's the area of the entire sector, but remember I only want the area of the shaded part, so I need to figure out what the area of this triangle is. If you remember area formula for a triangle is 1/2 the base times the height. All right, well, what's my base and my height of that triangle? Well, they're both, the radius here was 8, right? Well, the base and the height, they're both going to be 8 in this case. So I'd be 1/2 times 8 times another 8. All right, when I punch all that in my calculator right there, I should get 32 for my area of that triangle. So now I have my sector area right here. I have my area of my triangle right here. I need to subtract those two things to get my final answer. Okay, so my final answer here, I do 50.27, and I'm going to subtract that 32. All right, when I do that, my final answer for number 3 should be 18.27, and once again, that's going to be in meters squared. So there's my final answer. All right, our last question here is number 6. It says the area of sector ABC is 2 pi. The measure of the angle, the ABC, is 45 degrees. It wants me to find the radius of circle B. So no picture this time. All we're going to do is try to solve this for R. So this time, instead of finding the sector area, they actually give it to us. So I've rewritten the equation here. So I want to plug in 2 pi for the sector area. So 2 pi goes on the left side of the equation here. Okay, it tells me that the degree is 45 degrees, so that's going to go on top of the fraction. Still have 360 on the bottom. And then I can't fill anything else in this equation. I've still got just pi r squared, right? Pi r squared. All right, well, I have a pi on each side of this equation. I can actually cancel those off since there's one on each side right there. I'm just going to go ahead and cross those off. All right, after I do that, what I'm going to be left with, I'm going to make this fraction right here. That should have been 360. I'm going to make that fraction into a decimal instead here. I think that'll make this easier for us. So let's say 2 equals 45 divided by 360. That fraction turns into 0.125. And this now would just be times the radius squared, right? All right, so now I have this number out in front of, I'm sorry, not pi squared. That should be radius squared. There we go. All right, so now to get rid of that 0.125 right there, I'm going to divide both sides by 0.125. All right, once I do that, on the left side of the equation over here, I'm going to get 16. All right. These 0.125s cancel out, so I'm left with, on the right side, the radius squared. All right, well, we know that whenever we get to this point in any equation, to solve for r here, I'd have to take the square root of both sides to get r by itself. So r would end up being the square root of 16, and most of you know, without having to use the calculator here, the square root of 16 is 4. So my radius on that problem was 4. All right, and that's going to do it for sector area and arc length.